Hey guys, it's Miss Rainey. Today we are looking at part 5 of our Nomenclature and Reactions unit, and we are looking at balancing redox reactions, specifically using the half reaction method for those redox reactions that are a little complicated. All right, so when we get to balancing redox reactions, there are a whole lot of rules. So I'm going to go through the rules individually one at a time right now, and then I'll go through them more slowly as we get to a reaction with an example. So when you're balancing a redox reaction, it's going to matter whether you have an acidic solution or a basic solution. And most of the steps are the same. The basic solution just has one extra. So what we're going to do is separate the reaction into half reactions. We're going to balance everything other than hydrogen and oxygen. And then to balance oxygen, we're going to add water. To balance hydrogen, we're going to add H plus ions because those are in acids. We're going to balance the charge by adding electrons. And then we'll need to multiply the half reactions to equalize the number of electrons because we'll have to have the same number of electrons on each side. We'll add the half reactions together, we'll simplify the equation, and then we're going to check that everything is balanced. If you have a basic solution, it's basically the same thing. We're going to follow all the steps above to make a complete balanced equation, but then we're just going to add hydroxide ions equal to the hydrogen ions on both sides. And in the end, once you're finished, overall, there should be no electrons in that final equation, and everything, all atoms and all charges should be balanced. Okay, let's look at an example. All right, so this first one is going to be balancing a redox reaction in an acid or in an acidic solution. So here's our example, and it is in an acidic environment, meaning that it's floating around in something like water and hydrochloric acids. There's hydrogen ions and chlorine ions and water molecules that are just kind of floating around in that beaker. So let's look at this one step at a time. Our step one is we're going to separate this into half reactions. And so if I'm looking at this reaction, I see that there's a sulfur half with sulfate and sulfite, and I see that there is an iodine half with iodate and plain iodine. So those are my two halves. So let's start with my sulfate half, or sulfur half. I've got SO3, -2, turning into SO4, -2. And then for my iodine half, I've got IO3-, turning into I2. So those are my two different half reactions. One of them is oxidation and the other one is reduction. Now I'm going to balance all of the atoms other than hydrogen and oxygen. So I'm looking at balancing these reactions, and I see that there's one sulfur on the left and one sulfur on the right, so the sulfurs are good. But for my iodines, I have one iodine on the left and two iodines on the right. So I'm going to add in two iodates so that I can have two iodines, and my iodines will balance. So now I'm going to balance oxygen by adding water. So if I'm looking at the oxygen in this sulfur reaction, I have 3 oxygens on the left and 4 oxygens on the right, which means I'm missing an oxygen on the left. I'm going to balance the oxygens by adding water, so I'm going to add +1 water. For the iodine half, I have 2 times 3 oxygens, which is 6 oxygens on the left, and there are no oxygens on the right. So I'm going to add in +6 waters because that will give me 6 oxygens. Now I'm going to balance hydrogen by adding H+ ions. So let's look at my hydrogen. I have 2 H's here. Sorry, that color didn't work out. Let's try again. Let's use green. I have, oh, that didn't work out either. Hold on a second, guys. Let's use yellow. I have 2 hydrogens on the left and I have no hydrogens on the right. So I'm going to add in some hydrogen on the right, and it'll be 2H+ to balance with the 2. Otherwise, for the iodine, I have 6 times 2, which is 12 hydrogens. So I'm going to add in plus 12H plus to get all the atoms balanced. So now I should have all the same number of every atom on each side. My last step is to balance the charge by adding in electrons. So let me take out these colors. Hold on. So we can look at the charges. So if I am looking at the charges on the left-hand side of the sulfur reaction, I see that I have -2. If I'm looking at the charges on the right-hand side of the sulfur reaction, I have -2 for the sulfate and +2 for the 2 hydrogens, which means right now my right-hand side is 0, but I need them to be exactly the same. So I'm going to add 2 electrons to the right so that I get 2 more negatives, so that overall I've got a -2 on the right to balance my -2 on the left. If I do the same thing for the iodine, there's 12 pluses, and I have 2 negatives, so that's a total of 10 pluses on the left. On the right, everything is neutral. So in order to get these balanced, I'm going to need 10 negative charges to make the left 0 so that it matches with my right 0. That is plus 10 electrons. So now I have 2 completely balanced half reactions with atoms and with charge. So before I get to the next step, let me rewrite this a little bit nicer looking. So here we are. Here's the 2 reactions that we already had written. I have my sulfur half and I have my hydrogen half. I'm sorry, iodine half. And now we're ready for the next step. We're going to multiply the half reactions to equalize the number of electrons. Notice that I have 10 electrons on the left here, but 2 electrons on the right there. They have to be exactly the same. So I'm going to multiply that top reaction times 5 to get them exactly the same. If I do 2 times 5, I get 10 to make the electrons match, which means everything has to be multiplied by 5. So I'm going to add 5s into all of that. And now I'm going to add the half reactions together and simplify. So once I've made the electrons the same on both sides, those electrons will cancel out. So I can add these half reactions together. Everything on the left is going to go on the left, and everything on the right is going to go on the right. So that is 5 waters and 5 sulfites, 12 hydrogens, and 2 iodates. On the right-hand side, I have 5 sulfates, 10 hydrogens, 1 iodine, and 6 waters. But there's another part to this, not just add them together, but we're also going to simplify. And so when I'm simplifying, I see that there are 5 waters on the left and 6 waters on the right. 5 of those waters will cancel to leave me 1 on the right and none on the left. Same thing with hydrogens. I've got 10 positive hydrogens on the right and 12 on the left. So those 12 are going to reduce to just 2, and the 10 on the other side will cancel out. So that then, once it's simplified, let me rewrite it one more time. We end up with 5 sulfates, 2 hydrogens, 2 iodates on the left, 5 sulfates, 1 iodine, and 1 water on the right. And that should be it. Check to make sure everything is balanced. There should be no electrons in the final equation. Everything should just be good. So let's make that double check just to double check. I have, let's see, 5 sulfurs, 5 sulfurs. Those are good. I have 5 times 3, which is 15 oxygens, plus 2 times 3, which is 6. That's 21 oxygens on the left. 5 times 4 is 20, plus 1 is 21 oxygens on the right. 2 hydrogens on the left, 2 hydrogens on the right. And last but not least, I've got 2 iodines on the left and 2 iodines on the right. If we check our charges, there's 5 negative 2's, which is negative 10, and 2 positives, which is negative 8, and 2 negatives, which is negative 10 on the left. On the right, I have negative 10. So that everything is balanced. The atoms are balanced, the charges are balanced, the entire thing is balanced. And let me get rid of my little highlights so we can see it. My overall balanced equation. Let me put a fun little box around it. There we are. We have balanced redox in an acidic solution. Now let's try balancing a redox reaction in a basic solution. It uses the exact same process, it just adds one more step at the end. When we are in a basic reaction or a basic environment, we're going to do exactly the same things as we did before, just add one extra step. All right, so our first step is to separate this into half reactions. So I see that there is a sulfur section of this, and I see that there's a manganese section of this. So for my sulfur section, I have let me change that color. Yellow won't work. Let's make it purple. SO3 minus 2 and SO4 minus 2. For my manganese section, I have MnO4 minus and MnO2 without a charge. Now that it's separated into half reactions, I'm going to follow all of the steps that I did before, and I actually want you to pause your video now and see if you can get these two equations completely balanced without me, and then unpause when you've got it, and let's see if we've got it right. So pause now. All right, I'm hoping that you did. So now I'm going to go through it step by step. I'm going to balance every atom other than hydrogen and oxygen, which means I've got one sulfur, one sulfur, one manganese, one manganese. We are balanced. Now I'm going to balance oxygen by adding water. There are 3 oxygens on the left and 4 on the right, which means we need 1 water to add 1 oxygen. For the manganese, I have 4 on the left and 2 on the right, so we need 2 waters to add for 2 oxygens. Now I'm going to balance hydrogen by adding H+ ions. There's 2 hydrogens on the left, so we need 2 hydrogen ions on the right. There are 4 hydrogens on the left, so we need 4 hydrogen ions on the right. And then we're going to balance the charge by adding electrons. So for my charge, I have a -2 on the left and a -2 and a +2 on the right. So if I add another -2 on the right, that makes both sides equal to -2. For the manganese, there's 4 pluses and a minus. That's a total of 3 pluses. And the other side is neutral. So that means I'm going to need 3 minuses to get everything to balance out. So let me rewrite those a little prettier. Here we are, same equations. My next step is to multiply the half reactions to equalize the number of electrons. Do you see that we have 3 electrons on the left and 2 on the right? So that everything in the manganese half is going to have to be multiplied times 2. 3 times 2 is 6. 4 times 2 is 8. A 2. A 2. 2 times 2 is 4. And everything on the sulfur side will have to multiply times 3. 3 waters, 3 sulfates, 3 sulfites, 6 hydrogens, and 6 electrons. Now that my electrons are equal, I should be able to add the half reactions and simplify. That is, the electrons will cancel out because I have the same number on both sides. We can also cancel some waters. There's 4 waters on the right and 3 on the left. So 3 of them cancel out and we're left with 1 on the right. There are 6 hydrogens on the right and 8 on the left. So 6 of them cancel out and we're left with 2 on the right. And I think that's everything that cancels. So now we're going to add the whole thing together. And let's see, I got 2 H pluses and 3 sulfates and 2 permanganates on the left. And on the right, I have 2 manganese dioxides. There's a water, there we go, 2 manganese dioxides, 1 water, and 3 SO4 minus 2. If we were in an acidic solution, we would be good. We should be able to currently check that all of our atoms and charges are all balanced, the same number of sulfurs, oxygens, manganese, hydrogens, and charge on both sides. That is our balanced acidic reaction. But since we have a basic reaction, we have one more step. We did all the steps above to make a complete balanced equation, but now we are going to add hydroxide ions equal to the hydrogen ions on both sides of the equation. So since I have 2 hydrogen ions, I'm going to add 2 hydroxides to both sides. When I do that, the hydrogens and hydroxides on the left will become 2 waters. And now that I've got 2 waters, those 2 waters will cancel with a water on the other side to leave 1 behind. So that my final overall reaction will have 1 water on the left, no hydrogens because they combine with hydroxide to make water, 2 MnO4 minus, 3 SO3 minus 2. On the right, I've got 2 MnO2, no water because it canceled with what was on the left, 3 SO4 minus 2, and 2 hydroxides. My reaction should still be balanced with charge. It's just now that I have leftover hydroxide instead of leftover hydrogen. If we go back to check just to make sure everything's right, 2 hydrogens, 2 hydrogens. We've got 2 manganese, 2 manganese. We have 3 sulfurs, 3 sulfurs. For oxygen, we have 1 and 8 and 9, which is 18. And here we have 4 and 12 and 2, which is 18 oxygens. And then for my charges, on the left, there are, let's see, let me get rid of my highlights so we can see it easier. Let's try that again. There we go. For my charges, what we have is 2 negatives and 3 negative 2s. That is -8. And on the right, I see that I accidentally got rid of my S. On the right, I have 3 negative 2s, which is -6, and then 2 more negatives, which is -8. So my charges balance, my atoms balance, everything is balanced, and it's basic because it has that hydroxide in it. So there we are, a reaction that is balanced in a basic solution, and one that is balanced in an acidic solution. All right, hope you guys had as much fun as I did. I'll see you next time.